All right, section 1.4 in stats, we get into describing the distribution of a data set. So we've done stem and leaf plots, we've made some histograms, and now we're going to talk about how we can describe that data set and what data can look like to us. So the essential question is, how can I describe a distribution? And then there are some definitions. So symmetric is a standard bell curve where the mean and the median are both the same. So I'm going to zoom in and make a drawing over here. So that's where it comes up, it comes down, and it's pretty much even on both sides. For this one, the mean and the median are both in the middle. I know my drawing's not perfect, actually. Let me try to fix it. It would look more like this. It'd be coming down. Yeah, it's a little better. All right, skewed right would be if the right side extends further out. So the tail would kind of be off to the right. I'm going to draw that one over here. So skewed right would be if your data comes up and then it kind of tails off to the right like this. Let me do a little better at that. It would come up and then, man, this pen is, there, that would be a little better. So it comes up and it comes down to the right like that, where it's clearly stretched out more to the right. So in this one, the median would be here, but the mean would be in a different spot. The mean would be more to the right. So skewed right means there's a tail that goes off to the right. So it comes up and then it tapers off to the right. Like that. And then lastly, skewed left would be if the left side was further out, which means the mean is less than the median. So this one would look like this. You have your line. That'll be what skewed left looks like. So we'd have our median would be bigger than the mean. Okay, that means there's some really, really little numbers that bring the mean down, but the median would still be in the middle of the data. So half the numbers are over here, and half the numbers are over here, but those small numbers really bring the median down. Okay, and then there's also what's called the uniform, and this has the same height throughout. So it would look like this. It'd be just a rectangle. So that would mean, like, if you had a class of 20 people and you took their heights, if all 20 people were the same height, it would look like this. Or if you had, we're doing the age of people. Let's say in one class, every single person was the same as age. It'd be the same height. That's what we're looking at here. Right. When describing a distribution, the following should be identified. We should give the center. So we give the median. Where's the center of the data? We should identify the spread or the range. So how far apart? And then we should identify the shape. And then we should identify writing a general conclusion. Okay, so center, shape, spread, and conclusion. Right, so in the histogram at the right below represents the exam scores of 27 students. Describe the distribution. Okay, so if I were to draw a curve, the curve would look like that. All right, so let's start with number one. Number one would be find the center or find the median. So if there are 27 students, what is the middle of 27? The median would be the 13th or 14th student. If there's 27 total and you lined them up, all 27, the middle will be between the 13th and the 14th student. So we have to find the median. So if we count these up, how many students score between 0 and 10? There's 1, there's 2 here, there's 3 here, there's 4, 5, 4, 3, 2, 2, and 1. So we got to find out where is that 14th student. So let's count from the left. There is 1 student here. When we get to here, that's 3 students. It's 1 plus 2. When you get to here, that's 6 students. 1 plus 2 plus 3 is 6. When you get to here, that's 10. And over here is the 15th student, because if you add up all these, that's 15. So that means in this column right here, this is where that 13th and 14th student is going to end in. So where is the center? It's between 40 and 50. So center is 40 to 49. That's the center. Number 2, what is the range? So what's the smallest score and what does it go up to? The range is between 0 and 100, so the range goes 0 to 99. And what would you describe the shape as in step 3? The shape would be skewed left, skewed right, uniform, symmetric. This one I would say is symmetric. Notice how it's kind of even as you go up and you come down. It doesn't tail off either direction. And then for number 4, it just says to write a sentence making a general conclusion. So what we could say about this is most scores are between 30 and 60. Okay. And that there, so because most of the scores are going to be in here, right? So we can say, yeah, the majority or most of the scores are between 30 and 60. And that's what we're looking to do when we describe that distribution. You can see in this picture that most of the stuff is in the middle. It's kind of like most test scores in a class. There's not many that usually are 100%. There's not many that are really, really bad, but there's a lot of them that are in that middle, that B range, that B to C range. All right, example 2, we're doing the same thing. It says the relative frequency histogram below represents the percentage of people who drink beverages from plastic bottles per week. So it'll be like, what percent drink 1 to 2? What percent drink 2 to 3 plastic beverages? How many drink 6 to 7? It kind of shows on the bottom there. So what is the middle of a percent? Like you're talking percentages, what's the middle? 50% would be the median. So in our first step, we're looking to find what is the median. So in the first 2 columns, it looks like it's 3%, 3%. The next column looks like it's 10%, then 12, then 18, 26, 22, and the last one looks like it's 8. We're just trying to see where is 50. So if you would do 3 plus 3 plus 10 plus 12 plus 18. So we're working from left to right. 3 plus 3 plus 10 plus 12 plus 18. That will be 30, 40. This will be 46. So 46 would be all the way up to here. So once you get into this column right here, that's where the 50th percent is going to be. That's where the middle is. So the center is in this column. So we know the center is going to be 6 bottles. Okay, we'll say 6 bottles. You could say 6 to 7 bottles. We'll say 6 bottles. This is 1 bottle, 2 bottles, 3, 4, 5, 6 bottles, 7 bottles, 8 bottles. And nobody drinks more than 8 bottles. This is what the data is showing. So the second one is, what is the range? So what is the lowest number of bottles? Well, people who drink 1. This is including people who drink plastic bottles, so we're not going to count the 0. And it goes up to 8, right? Because this last line ends just before 9. So the range goes from 1 to 8. Step 3 is, how would you describe the distribution? So if I draw a line now, I'm going to go with the highlighter. How would you say that that is shaped? It looks like it tails off to the left, right? So we could say the data is skewed left. And then step 4 is just write a general conclusion from this. So how many plastic bottles or how beverages from plastic bottles do people drink per week based on this? So it looks like most people drink, it looks like from 5 to 7. Looks like they're in this category as the majority. So most people drink 5 to 7 beverages. This would be beverages from plastic bottles per week. Okay. All right, and then we got one more problem with a box plot. Oops, actually 2 more. I was wrong. So in example 3, it says below is a box plot representing the distribution of a random sample of 20 concentrations of calcium carbonate in milliliters per liter. Describe the distribution. So first of all, we want to find the center, which is the median. So that'd be 1. The median in the box plot is right here. So about how big would you say that is? It looks like it's directly between 131 and 132. So we would say the center is at 131.5. That is milliliters per liter. All right. The second thing we're going to find is the range. And so to find the range, we go from the smallest number to the largest number. So this ranges from the smallest number is 128 to the largest number, which is 135. And then number 3 says describe the shape of the graph. So if you remember box and whisker plots, if each side, so the left side and the right side of the median is both the same, so notice that, let me get a highlighter, from here to here and here to here is both the same. And also from Q1 to the median and Q3 to the median are both the same. So we would say that this is symmetric. It's not skewed either way. And then number 4 is just write a statement about the concentrations. So what I have written down here is that half of the concentrations of calcium carbonate are between 130 and 132.5. So basically, change colors. This is Q1. This is Q3. 50% of the numbers are going to be in between there. So we're going to say half of the concentrations of calcium carbonate are between 130 and 132.5. Okay, we got one more example of a box plot. So consider the lifetime in years of a random sample of 139 Energizer bunnies. The box plot below shows the distribution. Describe the given distributions. So step 1, where is the center? So the center is the median. Median is right here. So here's 0, here's 5. It's definitely closer to 0 than 5. I would say somewhere around 1.5 years. So the lifetime of the Energizer bunnies in this sample, the average or the median is about 1.5 years. Okay. The second thing is find the range. What is the range of this? So the range goes from the smallest number to the biggest number. Now this outlier, these green dots are outliers on the right. They still count as the range. So the range goes from 0, the smallest one is 0, up to the biggest one looks like about 12. So it ranges from 0 to 12 years. Step 3 is the shape of the data. So if you look now, the left side of the median is where the yellow line is. The right side, I'll keep it yellow, goes all the way out to here. So you see how on the right side it goes way further away from the middle? So we would say that the shape or the data is skewed to the right. And lastly, just write a sentence describing the data. So it looks like the or half, if you look here, half of the bunnies are from the median to here. So we would say half of the bunnies, the Energizer bunnies, live 0 to 3 years. Actually, sorry, I screwed that up. That should be a 1. It should be 1 to 3 years because here's the 1 and here's 3. So half of them are in the middle there. And then I'm going to say with outliers at 8 and 12. I do want to point out that you should always list the outliers if there are outliers. So in that summary at the end, you should say where the outliers are. So this one, the outliers are at 8 and 12.